Hi, my name is Chmarny. I'm actually Polish, and I wanted to do some of that part of the session here in Polish, but I realized my technical terms are so weak I couldn't even get through the first sentence. It's actually pronounced Chmarny, I'm told too, so I'm learning very quickly. All right, so I want to talk today about Knative. Knative is an open source project that you might have heard a couple times already at conference. I attended a couple sessions and actually came up in topics, so I'm going to go deeper into this, and I want to talk about the world of serverless. First of all, just to give you a little context of where I come from and how I'm going to phrase and how I'm going to position serverless, let's talk a little first of all. Oops, too many slides. What I wanted to do is, first of all, say that serverless, in my opinion, is bigger than functions. So if you go into a UI and pasting some dynamic language and saving it, that's part of it probably, but it's not the serverless as we know it, I think, today. What I mean by serverless, when I mean that word, I mean that there's certain operational models and developer models. In operational models, obviously there's no servers because it's right in the name. The security is managed for me. There is a certain amount of trust that I'm believing that the operator is going to do, a certain bare minimum. I'm paying only for what I'm using. And as a developer, it's all through APIs, event-driven, and the important part that is open and portable. And we're going to talk about a little more. So serverless, the second thing is serverless and a container. There's a number of articles and posts and blogs out there talking about kind of proposition of or serverless or containers. Which one is better? And I think the talk I'm going to give today and the details and the demos, I'm going to show you how you can have containers and eat it serverless. It was supposed to be cake analogy, but I got lost somewhere there. All right. So with regards to containers, why even containers? Well, first of all, it allows us to kind of bundle the description of the workload. So any library, any language, any OS, based OS, and deliver that when it's compiled as an image to the place where we need to run it. So it kind of gives us both a very common unit of describing the workloads, which is generic and abstracts from the specific implementations in languages, and then gives a nice envelope for the workload to be executed with. And the third and final one is portability. I talked about this a little more about it being open, but portability, why is that important? Well, first of all, Kubernetes, which is the underlying platform underneath Knative, is very ubiquitous at this point. Basically, every cloud service provider you can imagine is offering a service for Kubernetes. You can use this sometimes with very light touch, only with CLI and APIs, or you can use you can have the entire access to it. Knative depends on that presence of Kubernetes being everywhere. It kind of treats it as a common ground and therefore is able to build a lot of nice experience for developers on top of that and make sure that those experiences are portable. With regards to Kubernetes, with regards to Knative, that's kind of like a grammar. The very same way you would use SQL for different types of databases, and there are some flavor differences, but basically if you know SQL, you know SQL. Similarly, in Knative, if you know Knative, you can go to different cloud service providers and use that API regardless where it's deployed. All right. So that was my 3 minutes, hopefully, intro. So let's talk about Knative. This feels very loud. Am I loud? All right. Okay. So Knative, when we first launched Knative about almost 2 years ago, we described it as an open source building blocks for serverless on Kubernetes. And to some degree it's still true, but it has evolved over time. And now it's basically a full platform. And by the way, it's pronounced Knative, not Knative or anything like this. I've heard a couple of deviations of that. Knative.dev is a good place to learn a little more about history, positioning, who is playing, and everything else. By the way, I will make the slides available afterwards so you can have access. When we launched it, we also talked about the primitives, which is basically if you assume that Kubernetes is underneath and is available to everybody everywhere, which is almost true, there are certain building blocks that you need in order to build a serverless offering. You need to have a build component that allows you to build those images and create them so that they can be used everywhere. Serving, which is all about like how do you respond to requests and manage and autoscale and everything else. And events, which seems to be a very key component of serving. So over the last 2 years, the project has progressed, and we've had pretty regular set of deliverables Every 6 weeks, there's a new release of Knative dropping. We have 50, I think those numbers are a little old now, so maybe like 60 companies who have contributed to the project. This is an open source project under Apache 2 license. 6,000 pull requests. You can see all those numbers. It's basically a vibrant community at this point. And the part that I'm most excited about is that we have individual contributors who are spanning beyond just the code. There's a ton of people who commit code, but the actually community now manages the documentation. There's a lot of issues, planning. We have 9 work groups, and these are led by people who kind of have a good understanding of technical area, but they also kind of manage and maintain that community. So there is a good momentum behind that. More information on that there. Whoops. So today, Knative is, having been around for quite some time, it has become a component of a service offering that is provided by a number of different companies. Google, you can see, has 2 offerings, Cloud Run, managed and hosted, as well as Red Hat and IBM have offerings based on Knative. SAP has an open source project called Kima, and a company called Triggermesh here in Switzerland, I believe. Sebastian, former contributor to Kubernetes, is still active now in the community there. So a number of different products using those components, and they're building their own product with that. Why is it interesting? Because what it allows them to do is to deliver a much more catered and specific experience for the type of developers that they know very well. So it's not just generic open source, everybody has to use the exact same way. So how do I use Knative? First of all, you can go to, this being an open source project, you go to GitHub, you look the README, and you install it. So if you went to README for Knative, you would see an installation. There would be version specific to the time, but basically it would look something like this. You would install a couple YAML files for each one of the components. By the way, you can use serving by itself. So if you don't want eventing, you can kind of get a mini app engine-like experience just by installing the serving. More information on it there. If you're looking for the easy way, and again, most of the time I'm going to be sharing slides that are specific to the open source project. So I'm going to be keeping my Knative steering committee member hat on. This is where I take the hat off and say, a number of different cloud service providers have offering to provision the entire Knative stack much easier. Google, in this case, the one I'm familiar with, provides a UI and a gcloud command, which you can easily spin up. So if you have ever created a Kubernetes cluster on GCP, on GKE, you only add an additional flag called add-on equals Cloud Run. You're done. You run it, install it, Google provision the entire stack. There are similar offerings from IBM has a pretty nice UI. You can provide the different clusters. I think Red Hat has it in OpenShift as well, an additional flag. Whichever way you install Knative, there is a slew of all kinds of configuration options that Knative provides. Basically, out of the box, we work on the assumption of batteries included, which means you provision the Knative stack, you launch it, and it's good to go. You don't need anything else. But if you want to play with different variables and configurations around autoscale and networking, how we provision secrets and everything else, every one of those is exposed in the config maps. So I'm not going to go through each one of those, but you can kind of see the detail of different configuration we have there. So how do you use Knative? So now you have installed it. Let's say you went to GKE, or you installed your open source version on premise. Whichever way you got it, how do I use it? So we talked about Knative as being the 2 sets of components. There is serving and eventing. There used to be a build. We've donated build to continuous deployment foundation, which is now Knative is depending on the project called Tekton. Tekton has pipelines for builds. It can kind of create very complex and robust building implementation. That's kind of outside of scope for today. But with regards to serving, there are a couple key features and components that Knative allows you to do. First of all, there's the one that we most often talk about, which is the notion of auto-scaling. Whether you're scaling from 0 to 1, 1 to n, or n down to 1 and 0, Knative does that automatically. You do not have to manage this at all. And it's based on a request by default, which means that modern applications, they really are not often I/O sensitive, or they don't create a lot of pressure on the CPU because they're based on kind of horizontal scalability. So in order to address those kind of workloads, Knative scales on a request by default, which means the number of requests will be driving how many instances of the applications are being provided at any given time. it scales to 0 too, which means you can use your cluster for something else when it's not being used. The other part that's being very interesting to show, and I'm going to show each one of those in a demo, is the ability to manage the requests, routes, and path. And how do you manage access to each one of those? We talk about internal and external access, and how do you split traffic and manage their blue-green deployments, for example. There's a number of other capabilities around provisioning the custom domains or vanity domains, whichever way you prefer, SSL certificates and so forth. And it's also because it's built kind of with the notion that people will be reusing and building their own products on top of that, there's a lot of capability to extend it. So for example, you can bring, if you don't want to use the Knative build project, you can use Google Build, you can use GitHub Actions or Jenkins or something like that. Similarly with metrics, you can use GitLab for provisioning, or Solo for gateway, or Datadog for metrics. All right, let's go into this now. So Knative, for longest time, had no CLI because it basically was running on top of Kubernetes. We assume you would use CLI, which was great, and it still is. We provide the same capability. But there was a number of users who've never used Kubernetes, and they wanted to use Knative. They liked the features and capabilities that it provided. So we've created a KN. KN CLI is slightly behind Knative, so it offers the basics right now. But if you want to change configuration or see logs or something, you still have to go outside of it. It's getting a little better. There's a number of people contributing to the project right now. So I'm going to switch to just plain slides so we can jump back and forth, and I can do a couple demos. So first of all, what are we going to, can you see this? What we're going to do is we're just going to go KN service. Oh, probably not going to delete because there's nothing there yet. Create. We're going to call our application called Prime. We're going to provide an image path, and I'm going to explain each one of those once I run it, and I'm going to deploy it to namespace called demo. So KN will go underneath, we'll call the Knative APIs, invoke it, and provision. So if we go here, and get used to this UI because I'm going to, this is a demo application. I used to have a lot more complex applications for demos, and people were getting more interested about the demo itself than the presentation. So very simple application. You can calculate Prime, you can do it through REST, you can do it through UI, doesn't matter. So that's deployment through CLI. Whichever way you do it, by default, Knative will automatically concatenate the entire string for you and create a URL for it. So it will be the name of the service plus the namespace plus the domain that you've defined. You can customize it. You can customize it to remove the namespace, for example, if you're looking only to deploy to one namespace. The other way you can do that is YAML. We're still running Kubernetes. We're not hiding any of the power and capabilities of Kubernetes that you have underneath. So if you're kind of a YAML type of person, how many don't mind working on YAML? That's good. Usually everybody just boos. So let's go here. kubectl is the command line you would be comfortable with if you're working with Kubernetes at all. Did I hit enter? Oh, there's. So kubectl applied with a YAML is kind of normal pattern. There's nothing specific to Knative in here. So what are we going to do now? I'll call this max prime, I think, because the other prime was already taken. The same thing, you see manual deployment here. Which as a release, you can keep running over and over. You can customize, you can deploy it, and so forth. But there's even simpler way. Again, there is an open source CLI called Knackle or KNCTL, depends which way you want to pronounce it. There's OpenShift by Red Hat, I guess now IBM, and an IBM Cloud itself. But Google provides also its implementation of how to deploy that through its own CLI as well as UI. So back my Google hat on here. Let's take a look how this would look like. So Cloud Run is basic product, but I have application in here. Let's deploy a new version of this. You would look through the images that were previously built, and I can use, obviously, Cloud Build and other tools to do that. You would choose the image of your choice. and just go YOLO deploy. Okay, that's embarrassing. Should have been a little faster. So you have a UI deployment. Very same pattern. Doesn't matter which way you got there, whether you deploy through kubectl, KN, Canonical, any one of the other ones, you get that auto-scaling out of the box. So again, as the requests come in, the workload is woken up, because maybe there was not even a single instance. The workload is woken up, configured, and traffic is sent to it. When more traffic is required, you can send it. And because it's all configurable, you can actually go into a single thread mode, a single concurrency mode, which means that every single request will go to the brand new instance of container. Let's say you're bringing some legacy workload that has state managed inside of it, and you're afraid it's going to be reused or something. You can do that. If you're looking for a little more reusability, you can send. I think by default, Knative comes with 80 concurrent requests per container, but you can customize it, and depending on what type of VMs you're using underneath. The other options, the other ways to kind of integrate or deploy it is through different patterns. I'm going to go through those quickly, maybe we'll do a quick demo. So first of all, if you're kind of working in real life, you probably are not deploying from a laptop to a machine to a server, right? It's probably not kosher practice. So if you're using something like GitOps, or you're using Cloud Build, or using GitLabs or Jenkins, you have deployment that's happening from the servers, not from the actual laptop. So let's do a quick demo of that here. Back to our Max Prime application. This is the GitHub repository. You've seen this already. So if you, assuming as a developer, you were doing develop, git commit, git push, blah, blah, blah. Eventually somebody comes in and goes, you know, this is ready to go. You've done through a QA, QC procedure. And I'm going to cheat here a little. Obviously, you would probably do a little better job. Don't do this at home, but normally you would provide a little more information, hopefully do some work. What actually has happened is that there is a trigger configured on one of your CI/CD tools. So in this case, Knative works with Cloud Build. So let's see if we can find... I apologize for this microphone. How's this? Better? You guys awake? All right. There's a trigger configured here, first of all, that says that whenever a build is committed with a specific label, so you see me kind of naming the release something. So any release will be deployed to a particular server. So let's go into history. In this case, we have a test, build manifest, push, container, and deploy. Each one of those steps we're going to go through. Usually takes about a minute. So let me switch over here, walk through the other ones. We'll come back to the demonstration later. The other way to do is if you build containers using Docker, there's no reason to switch. You can continue using Docker build, Docker tag, Docker push, keep going and keep doing this over and over. You can use any one of the other CLI I already showed you to deploy that image. So you can kind of, what we call this is a kind of a chain of pearls. You connect individual steps, and each one of them is independent, and you can build the kind of pipeline that's good for you. So Docker build, Docker push is one way to go. There's uncluster. I talked about Tecton pipelines. If you're looking for much more complex and a robust set of pipelines, like an eventing pipelines, where you split the workload, build two things, then bring them together, Tecton pipelines have a nice way. It's based on Knative build, as well as a number of other contributions from CloudBees and others. So I would encourage you to take a look at that. And then finally, if you're a Go developer, and who isn't, you have another option where there is no containers or YAMLs at all. You literally go co-apply, and it just pushes automatically behind the scene. It's super fast. So if you're looking for this reiterative deployment, boom, 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 this is you're good to go. There's another open source project that I just don't have enough info on, but it's developed by a fellow Googler there that does that for all the languages. And stay tuned on that. It's open source already. I think somebody's already talked about it. Let's check on our demo in here. Okay, so all the steps completed. Max Prime, right? Yeah. So what you see now is, in addition to the normal application, we also see the release number that was passed from the build pipeline. And if you clicked on this here now, this is for demo purposes, obviously, your application will be more complex. But you can go to a particular release version, review the code that was used for this particular version. This is so simple, you can set it up. In fact, the pipeline, the manifest that defines it, is almost exactly the same for all of those. The only thing that changes is those variables where you want to deploy it. So it's super easy to reproduce. All right, so we talked about the different integration. Let's talk a little about how you use Knative in the two different type of patterns. First of all, it's a public service. You build a container, you push it, it's accessible to the wide. This is great for websites, APIs, and everything else. You might have an authentication inside of the application, but you don't really do anything special to manage the actual traffic. The other one is called internal service or cluster local service, depending which way you want to call it. And it's good for kind of a set of microservices that only one of them has to be exposed to the outside world. It's good for kind of processes that are not invoked by public, but by some kind of cron job, like a cloud scheduler or some kind of internal process. So let's review this. So I have deployed here a service that, given an image, will tell us what logo is in that image. And this used to work, so let's see. So in this case, there it works. So I'm glad that we are able to recognize our own logo, so that's good. You can send more complicated images. That's not the purpose of the demo. But what I'm trying to show you is a public API that was able to invoke externally, and it was all the way from here, from my laptop, and I got a response back from the API that deployed in a cloud. So what it looks like, actually, let's go back here quickly. So you say, oh, great. You know, what I want to do is I want to front that with another service that will give you people a UI and hide all the other services behind the scene. So we have our UI here. This is, you know, normal auth, you're authenticated, but eventually get to this point where you are able to choose the image, send a request, and there's the image. So you've done your job. You've protected it with external. Everything is great, right? Well, actually it isn't. Because what you've done is you just provided a path for users to go to the UI that you wanted, but there's nothing stopping somebody continue going to the CLI and using your credits. And who wants to pay for somebody else's credits, right? So what we're going to do is we're going to come in here. This is a manifest, basic manifest for that service. It has the name. It's implementing a service, Knative service. It's using still alpha. We are in beta, so I apologize for that. It has an image that we pointed to last one. Normally, you probably would go with a SHA. It's not a good practice to deploy with a latest. And then a couple of variables. Let's call this the, where's it right here? So what we're going to do is the same apply, kubectl apply. Hopefully it's faster now. Okay. So what happened now is we're back to our UI somewhere here. I can get rid of this. Let's refresh this. So back in our UI, we continue working. Everything is working. But if I come here, and let me do a verbose so we can see actually what's going on. You guys let me commit this without actually. Come on. I'm jet lagged here. Sorry. I keep forgetting if it's... Yeah, I think it's 2 spaces. Okay. It will tell us. So let's apply this again. And now, what we see is a 404. Hey, it's not like we have protection on it. It's not like authentication or anything like this. I literally removed the route. It's not accessible from outside. But my UI application, now you guys were thinking I was cheating, right? Let's choose YouTube this time. Come on. There it is. I don't know why it's so slow today. So we can do this. Let me come back to this slide. You can do this so the general public is exposed to a single endpoint, which is able to receive the external traffic, and behind the scene uses the cluster local. This is a Knative term for identifying a service to be only accessible externally. Okay, so similarly to all the other aspects, in Google you can go to simple UI. You can just say, hey, I want this to be internal, external, Bob's your uncle. You're good to go. All right, so we did the basics. We went in, you came to a great conference, Cloud Native in Warsaw, you saw Knative, you got excited, you went home, you built your application, you deployed it. It's great. Now you found a bug. Well, I would have a bug, you wouldn't. But let's imagine you have a bug. And you go in and want to update that application so that the application fixes the bug and serves the new traffic. But you actually have users now, so you don't want to bring them down and disappoint them also. So how do you deal with what's called day 2 problems on Knative? Very quick stop to kind of review the object model. Super simple. We have a service. You've seen the service in action when I was deploying the service. We have a route, which is exactly what it sounds. It's just routes traffic from outside to internal revisions. We have a configuration, which represents the code and the configuration of that service, which is frozen, is immutable, it cannot be changed, which means you can always go back to another revision. Say this again. No, actually, remember when I talked about Kubernetes being kind of everywhere? It's underneath, it just converts everything to Kubernetes objects and configures them the same way. So if you deploy Kubernetes on-premise, you went home today and you deploy your private data center Kubernetes, and if it's a Kubernetes API compatible service, I don't know how that wouldn't be, but then you would be able to deploy this Knative on top of this, and those objects will be created for you automatically. So actually, how's this? It's better. What actually happens is when you install Knative, Knative installs a few more CRDs. CRDs like the custom resource definitions files that describe the objects that Knative wants on the cluster. And from then onwards, it's just like it would normal Kubernetes, except you talk to Knative API, and Knative API makes it all the other objects. So there's a lot of efforts in Kubernetes itself, not to go higher up the stack, to kind of make it very specific to a deployment or platform. It's just very basic core objects. Knative takes a little higher and makes it much more easier to use. All right. So now there's a simple way to manage revisions. You can go to UI and you can select revision, may say active, which will hold the requests, change the revisions, and send the traffic to the new one. You can do this through kubectl by listing the revisions, finding one of the IDs, or the name in this case, editing this Knative service. This is abbreviation for it, sorry. It's K service. There is a service object in Kubernetes called service, so we had to create a different service, so it's K service. So you go to the object, you change the revision, and you're done. This is a very simple way, and if you're looking for immediate switch, this is all you need to do. If you're looking for what's called blue-green deployment, which means you want to have some confidence that the new version you're deploying is actually valid before you start sending traffic to it, you go through a three-step process. You go deploy, you have normal version. You deploy a brand new version without sending any traffic to it. You can, in Knative terms, what actually happens, it creates a named route which allows you to take a peek at it, but it's not that route that everybody else is using. It's totally different. So you can go at it, take a look, review it, and all that. When you're happy, you go in and you start switching. And you can do it either 100% switch, or you can do incremental and maybe some experiments, like, hey, send 2% of the traffic and kind of monitor the metrics and see if something is working or not. There's a demo in my GitHub repo, just a sideline, that shows how to use Knative for experiments by monitoring metrics around clicks on a screen. It's not a good A/B testing platform, but for simple use cases, you can actually solve it. So let's go through this demo, and I'm going to show you how to do this in 4 easy steps using Knative. So in this case, let's first of all deploy our normal service. So we've seen this before, so this is nothing different in here. I've deployed a service, and for purposes of demo, I'm colorblind, by the way, so I'm trusting this is blue, but if you haven't noticed by the slides already. So we have our basic application, it's running, we have users now. Now we need to go to stage 2. So what we want to do is we want to deploy a brand new version or brand new revision of the code, but not send any traffic to it, and create a what's called named route so we can take a peek at it. Let's do stage 2. Okay, so go back to our, we can close this. We can continue refreshing. This is still, everybody's seeing the exact same old version, but I don't know if you guys are going to be able to see. There's a named route to it, and how that happened, let's take a look at this here. Oh, that's the wrong one. So in our manifest, we were able to define the traffic in addition to it, and we were able to say, for our candidate, we want to go version 2. That's why the URL has the word candidate in it. You can change this. It doesn't have to be called candidate. You can, call it version or whatever you want. So going back to our kind of sequence. So we have created a service. We deployed it. Now we have a new name route. We validated that it's all good. What we're going to do now is incrementally start switching. Now this is demo, so I'm going to go, live only once type of thing. We're going to go 50-50. All right. Don't do this at home. So now if we go to our application, now this is not exact science because there's a number of revisions involved in here. Oh, sorry, I keep refreshing on this candidate. You guys not keeping me awake here at all. All right. What happened? Oh, I fat finger is again? There we go. So every 50% of the time, every second, it's not science, like I said, it's kind of trying to balance everything. It will do this. So now, assuming everything worked, when we were happy incrementally changing the versions, what we can do now is we can go all the way to 100%. So let's go stage 4. We actually did not remove the old route. We created another route that allows us to continue going to if we wanted to explicitly, but all users are going to be sent to the new one. So now, if we refresh, it will be just version 2. Now, imagine you had a bug and you really wanted to, hey, I need to go back to the last previous version. In our previous ones, we have the version still there. The revisions are still defined. So we can actually say, hey, to any, not just the last one, but to any previous revisions, you can deploy it. I think Knative actually cleans the revisions, so I think by default it's like more than 30 or more than a month or something like this, which all of that is configurable. So the revisions are not just sitting there, but it will take a while before you have this. So let's go back and apply 5, and hopefully by now we'll go back to our version 1. That's embarrassing. 1. Typing sitting sideways is not fun. All right, so we're back in 1. I think there's some Chrome caching going on there. So super easy to manage revisions and deploy it across different versions. By the way, just like with all the other use cases, you can go click the manage traffic, go to the UI, define the traffic the way you want, and apply it. Or you can do explicitly with those radio buttons. All the radio buttons are still not working as of today. All right, so you've seen the serving. This was all about serving. Let's switch the gears a little and go to eventing, because on the end of the day, a lot of what we believe to be serving is related to how you invoke events, how you send events, and how you communicate them. What do we do with regards to functionality in Knative for events? First of all, there's a lot of webhooks been around for a long time, and you can start sending events back and forth, but there is nothing really that allows you to declaratively define how those events should be managed, meaning that if the cluster was destroyed and you wanted to bring in the exact same state, Knative allows you to define them just like in Kubernetes itself with a declarative API, and then the Knative will resolve all the state of each one of the services to the desired state. So first of all, declarative eventing. The other one is that it allows you to define these different bindings, like a glue that connects the different triggers or sources, whichever you want to call them. We've renamed this like 5 times since I started the project. Brokers, triggers, and services, and you can define the binding between each one of those and how they connect to each other also in a declarative manner. And the third one is that whether you're looking for a very simple, hey, there is a importer that brings, I don't know, GitHub events, like commits or something, to a service, that's a simple trigger fire, or whether you're building a very complex pipelines, Twitter, translation, state, or something, and then show it to the UI, all of those can be implemented in Knative using the exact same grammar. So you don't have to learn new language for simple versus complex pipelines. The other thing, the interesting thing that often comes up with when I talk about Knative eventing is that it uses CNCF, so you're familiar with CNCF, events, which is very kind of open standard for how you describe the envelope for events. So it gives you the kind of like a WSDL used to be for web services, except it's not XML, don't worry. But it gives you a kind of an envelope which you can identify and route those events without opening each one of those events over. Just like with other ones, we have, there's a default implementation that is, remember, the basic principle behind Knative is batteries included. So the default implementation for broker, the thing that carries those messages, is in memory, because we don't want you to install a whole Kafka stack before you even have a chance to play with it. But there are other implementations. There's PopSub, Kafka, NATS, that you can simply switch, and all of them are provided with Knative. Just switch in the configuration, apply it, and when Knative reconciles all those changes, you suddenly have a message broker that's durable. Well, in case of PopSub and Kafka, you have durable. I'm not sure NATS is durable. All right, so what's available already? This list is just some that I picked them here for a slide, but there's a number of event importers. I have to stop myself because they were called sources until about a month ago. There's a number of Knative importers that allow you to bring those events into the Knative cluster. So no programming required. You bring one of those, you configure it with the required parameters, and you're good to go. There's a complete list over here. What actually these events do, and this is going a little deeper in CloudEvents. So if you imagine that an event, something happening somewhere, it's different for each one of the sources. So FTP has oranges. GitHub has some triangles going, and Google Cloud Storage has Pac-Man, I guess. What we need to do is the sources are able to understand on one hand what that language is on the other side and translate them into a common CloudEvents, and CloudEvents is this common format that allows us to define them and bring them in cluster and start routing them around. You see a little envelope over here. Obviously, the payload is obfuscated in here, but you can see that who was the source of the event, what the data type for that particular event is, so you can dynamically assign different processors for it. How am I doing on time?
Oh, sorry. You're fine, you
Quick overview of the model. So we talked about the importers. Good thing I updated the slide. We have broker. There is one by default for every namespace that you label with eventing, but you can create n number of them. If you want to keep them separate, you can do that. There's number of triggers that you can assign for each one of those brokers that connect you to the services. And because this is like connecting one to the other, you can stitch them together. So you can say this to this to this to this. So let's, I'm going to skip through this because you can look the YAMLs later. Let's go to a quick demo. It's not going to be quick, but let's go try to be quick. I'm going to use Knative to create a pipeline that sources events from Twitter. This is audience participation, so bring your Twitter applications up, whatever fonts, whatever you have. It brings, it loads the Knative source, which loads the events from Twitter for any tweet that includes the word Knative. First of all, what we'll do is make sure that we'll record everything, so we'll store each one of those into Firestore. Don't worry, I will delete it afterwards. The other thing that it will do, it will try to analyze the natural language process, each one of those tweets. So whether it's positive or negative. Because this video is being recorded, what I'm going to do, I'm going to send the negative to Slack so our team can see it, but not you. And the positive ones, I'm going to send to the browser so you can see it over here. Now, this is event in Poland, so you probably are going to tweet something in Polish. Our API by default doesn't understand Polish as of today. You have to specifically, explicitly say this is Polish. So what I'm going to do is when I see one of those non-English tweets, I'm going to send it to a translation API and then shove it back onto the same pipeline to reprocess them later. Does it make sense? Let's see if we can do it in 6 minutes. Or 5 now. So I have all those files in here. Let's do a quick... We've done with this. We've done with this. So this is my source. It has only one parameter saying query Knative for the word. It has a Twitter API that is stored as secrets in Kubernetes because remember we're running on top of Kubernetes, so all the capability of Kubernetes itself is still there. We have our store. These are much simpler because they don't have all those secrets in here. And for each one of those, we also have this concept of the trigger, which means that what I'm going to be looking is only for events of type Twitter. All the other events that arrived on Knative will not be processed by this demo. And then we're going to have a little visualization application on the end that it's going to bring a WebSocket application that is going to monitor those cloud events and display them, hopefully. So let's do this. I'm totally jet lagged, so tell me if I mistyped something here. No, looks like it's working. And normally you would create each one of those individually, but because we're running fast in here, what I'm going to do, we have our tweet. All right, so please keep it PG. This is being recorded. I'm going to get in trouble if you start tweeting something that is not appropriate. Can you tweet something with the word Knative? Anybody? Well, this has to be after the application. It's okay to retweet. It's okay to retweet. Come on. As you feel. Remember, the negatives are not going to go in here. There it is. Thank you for keeping PG-13 too. So this application really is just for demo. Clearly not something, I'm going to close it very quickly because this is recorded, like I said. I've done this demo before without the NLP. The NLP got created because of demos and people's like, let me say what I can say on a video. So hopefully you have seen how easy it is to create the events. Now, I really glanced over the events because there is a lot more to it. But by simply binding the triggers to a broker and broker through a trigger to an actual service, you can create pretty complex pipelines. And not just linear ones like this, but ones that are kind of more acyclical. They connect to each other regardless of which one it starts. There's a number of other demos out there. I created a shorter link for you to go directly to it. So you have a cron job, fire an event every time X happens. Processing IoT events, so we have connection to different IoT gateways. Pops up, actuators from Kubernetes itself. So eventing on Kubernetes for Kubernetes events. It's like looking in the mirror, seeing myself looking in the mirror, looking myself sitting in the mirror. Two more slides, almost done. Very quickly, like I talked about this a couple times, but we're sitting on top of Kubernetes, which means that all the power and capabilities of Kubernetes is still there. We're providing an abstraction layer with Knative, which hopefully you're leveraging in your normal day-to-day development. And for the normal flow, the products that built on top of this, you have very optimized experience in those products. At any given point, when the product is not able to do something, you can reach behind, and for that one use case, use Knative or even Kubernetes itself. So in closure, hopefully this was informative. There's a number of resources out there. This is a much bigger project, so it's hard to kind of give you an overview in 45 minutes, but hopefully kept you awake for after lunch.